Chauncy Harris was born in 1915 and grew up in Utah while his father was president of Brigham Young University. He won a Rhodes Scholarship to Oxford and then worked in the U.S. State Department as a geographer during World War II, where he first became interested in the geography of the Soviet Union. He spent most of his career at the University of Chicago. Harris died in 2004. Edward Ullman was 3 years older than Harris. After spending a few years in urban planning at Harvard, he spent the rest of his career in the geography department at the University of Washington. This article, published in 1945 at the end of the Second World War, established both Harris and Allman as leading geographers of their day. Review articles like this in the Annals of the American Academy of Political and Social Science are generally invited by the editors based on reputations that scholars already have achieved in their fields. Harris and Allman not only summarized several of the leading theories about urban structure and city location that were prominent in their day, but offered their own new addition, the multiple nuclei model, to the set of different conceptual models they reviewed. The article had an immediate influence on urban research and continues to be cited as one of the classics in this field. Harris and Allman began their survey of ideas in urban research by reviewing what geographers and historians have thought about why cities appear where they do. Because we usually grow up with a particular city as an established fact of life, this question might never even have occurred to us. But after all, every city is where it is for a reason. They take their first explanation for city locations from the work of German scholars who noticed that their comparatively crowded country had towns and cities scattered thickly all over the landscape. Of course, the methodical Germans looked at the countryside dotted with cities and began to see patterns. A skeptic might think that perhaps they were imagining patterns, just as the astronomer Schiaparelli thought that he could see patterns of canali, or channels on Mars, which turned out to be mostly optical illusion. But if we consider a map of Bavaria in southern Germany, even today we can see that the actual locations of cities do lend themselves to the sort of fractal repetition of pattern at different scales that the German scholars thought that they could see. Harris and Allman included a diagram in their article showing this repeating pattern. Starting with the largest city, in this case Munich, we can see some slightly smaller cities grouped around it at relatively uniform distances. The geometric shape with the largest number of sides, allowing the most different angles or directions, that completely fills a flat space like this is the hexagon. So the German scholars put one smaller city at each point of a hexagon surrounding the largest city. It's possible to treat each of these cities as the center of a smaller hexagon, and to put large market towns at each of the 6 points around each of these cities. When the towns become the center of their own hexagons in turn, we can draw in 6 villages surrounding each town. The nested geometry of villages, towns, and cities brought deep Teutonic satisfaction to its creators. Allman followed these scholars in explaining why such central places should reappear at larger and larger scales, from many small villages to a single central metropolis. According to this central place theory, at each larger scale, there are certain specialized functions and activities that don't make any sense in smaller communities, but if the population of a large enough area can be focused on the central place, these activities can be supported there. For example, every village may need to have a marketplace for buying and selling food, and today probably also a gas station. In the United States, nearly every little town gets its own post office and postal code, along with perhaps an elementary school, a church or two, and so on. But there may not be enough students for a high school, so the children from several small towns may come together in a larger town or small city for high school, and an even larger city for a college. Not every town needs a courthouse and offices for lawyers. Once towns reach a certain size, they attract banks and retail outlets. Cities host universities, hospitals, airports, and similar places that would not be suited to the smaller towns. And the biggest cities of all provide stadiums for professional sports, regional government offices, corporate headquarters, and other highest level amenities like a stock exchange. While central place theory explains why a large city like Munich may rise up in the middle of a surrounding territory, providing specialized services to smaller towns and cities around it, the second explanation presented by Harrison Ullman goes in a very different direction. If Munich, Berlin, or Frankfurt was the real-life inspiration for central place theory, the next theory was based on real-life cities like Butte, Montana, or Duluth, Minnesota. These cities exist where they are because large deposits of important raw materials were discovered very nearby. Butte sits practically on top of huge copper ore deposits that attracted the Anaconda Copper Company to come and build several gigantic mines there. Duluth is adjacent to the rich iron ore deposits of the northern Mesabi Range. In both cases, transporting the heavy, bulky ore long distances to be processed in distant cities made no economic sense, so smelting and processing plants sprang up in combination with the mines themselves, and this industrial employment base spun off countless other supporting occupations and produced the cities we find there today. The third reason that cities appear in certain places has become known as the break and transport theory, since at certain places we must unload the cargo of a ship in the harbor, store it in warehouses until it can be sorted out and dispatched on trains and trucks or by other transportation to new destinations. Along with warehouses come banks, hotels, taverns, laundries, restaurants, and all kinds of other stores and businesses in both the secondary and tertiary sectors of the economy. And the first thing we know, there's a city spread out before us. All of the earliest U.S. cities were located at breaks between ocean-going and land-based transportation, from Boston right around the coastline to New Orleans. Chicago and Detroit lie at the end of a water route that reaches deep into the continent through the Great Lakes, but even there, at some point, you have to unload the boats and load up wagons and trains, and that's where we find these cities. St. Louis grew up where the railroads running east and west crossed the Mississippi running north and south. Certainly you can extend this list indefinitely with your own examples. Sometimes this break in transportation is not so much from one type of vehicle to another as from one direction to another. For example, Atlanta is not a seaport, but that is where, if you want to run a railroad most efficiently along a fairly flat landscape, you can finally stop running south along the foot of the Blue Ridge and Great Smoky Mountains and turn west toward the heartland of the continent without having to climb up through any mountain passes. Harris and Allman also point out that once a city gets established for any one of these reasons, it may be able to add the others to the list and grow even larger. The biggest cities of all usually combine two or more of these reasons for existing where they do. Once they have considered these different explanations for city locations, Harris and Allman then suddenly shift their focus so dramatically that they almost might have started a completely different article instead. The rest of this article no longer concerns itself with where cities appear on the landscape, but instead zooms in on cities as complex landscapes in their own right. Urban ecology, reviewed first by Harris and Ullman, were already well known to all urban scholars even when they wrote this article shortly before the middle of the 20th century. Although these two models suggest very different ways of looking at the internal structure of a city, both of them have one thing in common. They both assume that it is possible to point to the center of the city, and this center contains pretty much the same structures and serves pretty much the same purposes in both models. The first of these, which had been suggested by Ernest Burgess 20 years earlier, is one of the most familiar models of city structure to this day. Burgess described a city as a pattern of concentric zones, like the nested circles of a bullseye target. At the center of the bullseye, we find the central business district with office buildings, perhaps some hotels and banks, and other related structures. Moving outward to the next ring, we find warehouses and some light manufacturing. Beyond that, Harris and Ullman suggest that we will find the residences of the people at the bottom of the ladder of education, income, and occupational prestige in the city, and that as we continue to move outward, crossing circle after circle, we encounter higher and higher social classes of people until we reach the commuter zone in the suburbs, where the most privileged residents of the city have their comfortable homes. The perceptive observer will note at once that this pattern of rising status with increasing distance from the center is the complete opposite of the residential pattern found in ancient pre-industrial cities, where the elites lived as close to the center as they could get, and the poorest and most disreputable people were forced out to the edges of the city. The reason, of course, for this dramatic difference between the concentric zones sketched by Burgess and the patterns found in ancient Babylon or Rome. We can understand this difference simply by remembering that the modern pattern of concentric zones is a byproduct of a particular historical period and a particular social and economic process going on in these cities. The period is the period of urbanization of society and urban population growth, and the process may be called deconcentration. The fundamental underlying process reappears as a theme running through most research on contemporary urban social life. The historical roots of the concentric zones can be visualized best by looking at the concrete example of one of the cities that colored the thinking of Burgess and that also was in the back of their minds when Harris and Allman wrote this article. Boston, in the British colonial period, just before the American Rebellion and independence, was the largest city in North America. A few years later, it boasted a total population of 25,000 people in the first census in 1790. This doesn't seem like much of a city today, but in those pre-industrial days, it was the best we could do. This early version of Boston is the starting point for the later growth of a great metropolis. While some people might describe the concentric ring model as a bullseye, others have compared these rings to the rings of a tree, added progressively over time, and locking details of history into each new layer. The tree analogy is completely backwards, though, because a tree adds new rings from the center, where the living heartwood grows, and the outermost rings are the oldest. With cities, it is just the reverse. The oldest part of a city like Boston is the center, what today we call the original walking city of the colonial period, because a person could conveniently walk right across the whole city from one side to the other in an hour or two and do any kind of business necessary in a single day. Urbanization and urban population growth occur with this central walking city already established. Industrialization brings factories to the edge of the original area and then more growth layers, new rings of residential development, further and further out beyond that. The oldest, smallest, least attractive houses in the inner rings are abandoned by people with enough money and flexible schedules, and the suburbs are born. The poorer people remain behind in the inner rings, just as described in the concentric zone model, which only makes sense for describing a city that has gone through this very special kind of historical transformation. As growth continues, the city gets larger and larger, and the advent of highways leads to suburban communities like beads on a string. In the case of Boston, traced along the inner ring road of Highway 129, which passes through one middle-aged suburban city after another. Then the freeways add an additional exurban ring, even further out, for Boston following Interstate 495 around the metro area at such a distance that people living out there may rarely go into the center of the city at all. Boston and the concentric zone model itself is a historical product. While the concentric zone model of Ernest Burgess was inspired by the gradual outward movement of people to newer and bigger houses, creating a spectrum from rich suburbs to poor inner-city neighborhoods, the complementary model suggested by Homer Hoyt concentrated instead on the dramatic transportation revolutions that helped to make this outward expansion possible. In their diagram of his wedge-shaped sectors of the city, Harris and Allman start again with the original pre-industrial walking city, which becomes the central business district later on. But this time the industrial area is not an inner ring, but one or more corridors running from the city center right through and out into the countryside. Homer Hoyt perceived that such manufacturing plants and warehouses tended to cluster along major transportation arteries, first roads, then later railroads, and eventually freeways. So the industrial sector shown here was also, above all, a transportation corridor. And as everyone knows, living next to the railroad tracks or a freeway can be a noisy, smelly, unpleasant experience, especially if there are also a lot of factories and warehouses and so on mixed into this corridor. So of course the people living in the neighboring wedges of this urban pie, closest to the rail lines and freeways and factories, will be the poorest people who have the least ability to get away from them. The highest status people, as shown in this diagram, live as far away from these industrial transportation corridors as they possibly can get. In any major U.S. city that grew up from a pre-industrial walking city past into our urbanized present, you should be able to find the different spokes of this transportation wheel leading into the central hub of the city, creating these different urban wedges that are usually well sorted out in terms of attractiveness and the status of the people found living in them. Concentric zones of Ernest Burgess's urban bullseye and the pie-shaped wedges of Homer Hoyt's urban sectors were modeled on concrete American historical experience, embodied in the actual layout of Boston, Chicago, and other eastern cities that already existed during the earliest pre-industrial days of the European colonial invasions of North America. But Harris and Ullman, writing this article near the middle of the 20th century, could already look around and see examples of real cities that did not fit either of these templates drawn from one kind of historical experience. If cities like Boston and Chicago are hiding behind the abstract circles and wedges of these earlier theories, it's pretty easy to see which city is hiding behind the abstract diagram that Harris and Allman offered in their article as a new, different third model of urban ecological structure. They called this diagram the multiple nuclei model, because what they rejected was the historically contingent notion that every city grew up by adding layers around a compact, much older pre-industrial walking city that became a single central business district. If you have visited many American cities, consider the diagram of their multiple nuclei model for a moment and see if you can guess which city inspired it. Once you know that this diagram fits quite nicely over the sprawling Los Angeles urban region, all the pieces should fall into place. Los Angeles has an original downtown, but it was so small and new when massive 20th century urbanization and urban population growth hit Southern California that it could never dominate the resulting metropolitan region. Competing centers like Long Beach, Century City, Anaheim, and other separate downtowns sprang up like mushrooms all over this region. Like Gertrude Stein's remark about her childhood home near Oakland, also in California, if we go looking for the center of Los Angeles, we might well conclude that there is no there there. But this multiple nuclei model for city structure is just as much a special historical byproduct as are the concentric rings and pie wedge sectors. Los Angeles is scattered all over an enormous landscape because it grew up during a specific historical period, dominated by the internal combustion engines of cars and trucks. If we adopt the perspective of Homer Hoyt and concentrate on the network of freeways that dominate the conversation of the Californians on Saturday Night Live, it is clear that the radial spokes of the wheel traced by Hoyt have become a rectangularized grid of horizontal and vertical arteries, meshing together to cover the whole area relatively evenly. It is still social organization, but of a different type for a different time. In fact, when they come to the end of their article, Harris and Allman recognize that all these static model diagrams remain limited by historical context and change, because they conclude that the greatest challenge facing any contemporary city, no matter which model it happens to resemble, is, quote, the constantly changing pattern of land use, unquote.